Hello, welcome. This lecture video is all about alkenes. So what are alkenes? Alkenes are also called olefin, and these are hydrocarbons that contain a carbon-carbon double bond. Alkenes are found in many naturally occurring materials like flavors, fragrances, and vitamins. So we have here some examples like ethylene. So ethylene is a plant hormone that induces ripening in fruits. On the other hand, alpha-pinene is a component of turpentine, and ang alam ko is turpentine is used to uh, lessen the consistency of paint. So, pinapalabnaw. So, parang ginagamit din siya sa thinner and ginagamit din siya for producing varnishes or varnish. And then we have here beta carotene. So, beta carotene, it is a compound that na meron siyang 11 double bonds, and it is an orange pigment. So it is responsible for the color ng carrots. And ang alam natin is beta carotene is a precursor of vitamin A. So vitamin A kasi is used as protection against certain types of cancer. So bakit natin pag-aaralan ang alkenes? So sabi ko nga kanina, carbon-carbon double bonds are present in most organic and biological molecules. So kailangan natin ng magandang ng understanding kung bakit bakit mahalaga yung mga alkenes. So in this chapter, titingnan natin yung consequences ng pagkakaroon ng double bond, and titingnan din natin or mag-focus din tayo sa mga reactions ng mga alkenes. So we have here industrial preparation and uses of alkenes. So ethylene and propylene. These are the simplest alkenes. So in order to create a double bond, you need two carbons. So yung pinakamaliit na alkene dapat ay may dalawang carbons. So ethylene and propylene, ito ay pinoproduce industrially. So, when you say industrially, ito ay mass production. And ano ba ang uses nitong ethylene and propylene? So, ethylene and propylene, this will serve as starting materials. So, starting materials ng iba't iba pang mga organic compounds. Like for example, ethylene or ethene is used to produce ethanol. So, ethanol, it's ethyl alcohol, yung ginagamit natin to sanitize our hands. So, we also have here acetaldehyde, acetic acid, also known as your vinegar. So, nanggagaling yan sa ethylene. And so much more. On the other hand, propylene, nakaka-produce din ng alcohol, which is isopropyl alcohol, which is used also for disinfection. So, madami din like propylene oxide, polypropylene, and cumin. So, paano na-produce ang mga alkenes? So, we have here a process called thermal cracking. So, yung thermal cracking, ito ay nagaganap or it happens for our alkanes with C2 to C8. So, 2 carbons to 8 carbons long na alkanes. And, ang nagiging product nitong process na to ay ethylene, propylene, and butene. So, isusulat ko. So, the products will be ethylene, propylene, and butane. So, this is, ethylene is 2 carbons, propylene tatlo, and then butane, apat. So, in thermal cracking, it may take place without a catalyst, but you need a very high temperature. So, in the process here, ano ang nangyayari? So, your 4 carbon long parent alkane will split into 2. So, magiging radical siya. So, magkakaroon ka ng dalawang ethyl to ethyl radical. And then after that is maaalis yung isang hydrogen, and in the process, magkakaroon ka ng formation ng double bonds. So here, butane splits into two ethyl radicals, then it will lose an an atom of hydrogen, and in the process, this will create, or this will produce, two molecules of ethylene. Now for the naming, so ito ay review na lang. So we have rules in naming your alkenes. So the first one is you name the parent hydrocarbon na dapat kasama yung double bond. Hindi dapat lalagpasan. So for example, this one, so this will be 1, 2, 3, 4, 5. So dapat madaanan yung double bond. So it will be pentene. Hindi siya magiging hexene kasi kinalimutan yung double bond dito. Okay? Next is you number the carbons in the chain so that the double bond carbons have the lowest possible number. So para ma-achieve mo yung lowest possible number ng double bond, you always start dun sa end kung saan mas malapit yung double bond. So like for example, this one, so kung dito ka magsisimula, mabibigyan mo, malolocate mo yung double bond between carbon 2 and 3. Kasi kung dito ka magsa-start, you will start here, 1, 2, 3, 4. So it seems na your carbon double bond is between 4 and 5. Pero hindi dapat ganoon. Kasi nga, dapat mabigyan natin ng mas mababang number yung carbon double bonds. So ito naman, if we will apply that rule kung saan sabi is dapat mag-number tayo kung saan unang makikita yung inyong double bond. So if you go here from left to right, you will have 1, 2, 3, 4, 5, 6. But if you start from right to left, you will arrive at the same number. So your carbon double bond seems to be located between 3 and 4. Either way, kaliwa kanan and kanan to kaliwa. So if this is the case, magsa-start kayo kung saan may unang first branch point. So when say first branch point, meron kayong substituent. So in this case, yung unang substituent na makikita mo ay at carbon position number 2. So that's why the correct direction nung numbering will be from left to right. Next. So you write the full name of the organic compound. So you number the substituents according to the position in the chain, and it should be alphabetical. There will be cases na nakabilog, so you will have a ring structure, so you will use a cyclo prefix. So let's give some examples here. So this one is given a name of 2-hexene because if you start here from this side, you will encounter a double bond between 2 and 3. So the direction is from your right to left. And so unang gagawin niyo dito ay bibilangin niyo yung kung ilang carbons yung parent chain. So we have 6, so that's why it's a hex. And then we use the suffix "-ine" kasi ito ay isang alkene. Now what's the number 2 before the parent hydrocarbon name? So the 2 will give you an idea kung saan yung double bond. So the double bond starts from carbon number 2 and carbon number 3. So yung double bond is between 2 and 3. So hindi na natin nilalagay kung saan kung ano yung dalawang numbers, kung saan carbon sila, pero kung saan na lang nag-start. So we have here 2-hexene. Here, so ito yung example kanina. So your methyl group is first encountered when you start from your kaliwa to kanan. So that's why the numbering will be 1, 2, 3, 4, 5, 6. So we have here 6 carbons, so that's hex. Then we use the suffix "-ine. Then you locate the double bond at carbon position number 3 and 4. So that's 3-hexene. Now, because you have a substituent at carbon number 2, that's a methyl. So we have here 2-methyl 3-hexene. So ito naman ay you will locate the longest chain muna. So dapat included yung double bond. So we here, so nag-start yung inyong double bond at carbon number 1. So you will count 1, 2, 3, 4, 5. So that's 5 carbons long. So that's a pent. Then you use the suffix "-ine", so pentene. Then the number 1 here will give you an idea that the double bond is between 1 and 2. And then you have here a substituent. So the substituent here is an ethyl. So met, et. So ethyl at carbon position number 2. So that's why it's 2-ethyl 1-pentene. Now this is a case kung saan meron kayong dalawang double bonds. So if that's the case, if more than one double bond is present, so you will indicate the position of each and use the one of the suffixes like di-ine kung dalawa yung double bonds. So kung tri-ine naman, it's tatlong double bonds yung makikita mo sa organic compound mo. So here, so what will be the naming? So ang rule natin is mag-start tayo kung saan may double bond. And it seems na in this case, if we start here, so the carbon-carbon double bond is between 1 and 2. And then if we start here naman, ganun din. So 1, 2. But since we have a substituent here, dapat ito yung unang ma-encounter natin in the numbering. So that's why the correct direction will be from your kaliwa to kanan. So paano natin siya niniman? So you locate the parent chain. So 1, 2, 3, 4. So that's a met, et, prop, but. So 4. Then, since we have two double bonds here, so we will use di-ine. So that means di-ine means meron kang dalawang double bond. Then, at carbon position number 2, meron kang methyl group. So that's why the correct name here is 2-methyl 1,3-butadiene. Here, so this one is in a ring structure. So if this is a ring structure at meron kang substituent, so paano natin siya nineman? So you always include the double bond. So doon ka magsimula. So we have here the yung double bond starts at carbon 1, then it's between 1 and 2, then 3, 4, 5, 6. So we have 6 carbons, so that's why it's a hex. And since it's in a ring structure, you use the prefix cyclo. So that's why it's a cyclohex. Then since meron kang double bond, it will be an "-ine". So cyclohexene. Now, how to assign the substituent number? So you have here a methyl group, and so yung methyl group mo is at position number 1. Kasi kung dito ka magsisimula ng number, pwede rin naman siya. I'm just giving you different scenarios. If you start here, this will become 1, 2. So the direction is counterclockwise. So ma-encounter mo daw yung methyl group at position number 2. Pero kasi since isa lang naman yung substituent natin, dapat yung substituent ay mabigyan natin ng mas mababang number. So magsistick tayo dun sa numbering kung saan yung carbon number 1 doon nagsimula in double bond. That's why the name here will be 1-methyl cyclohexene. Here, so we have here two double bonds, so that will give you an idea that it's a di-ine. Now, you count the number of carbons. Well, we have here a hexagon, so that will give you an idea that it's 6 carbon na naka-ring, so that's a cyclohex. Kaya ito ay maging cyclohexadiene. Now, you need to locate the position of your double bonds. So, dapat yung numbering nung double bonds mo ay mababa rin. So, in this case kasi, so sige, I'll start muna dun sa mali. Pag nag-start ka dito ng 1, 2, 3, 4, 5, so nasaan ang inyong double bonds? So, yung double bonds mo is between 1 and 4. So, sulat natin 1, 4. Pero kung susundin natin yung numbering dito, ay yeah, so tama pala. So 1 4 na pala. So the correct name for this uh, organic compound will be 1 4. So that means the double bonds are located between carbon 1 and 2 and then 4 and 5. So the name here is 1 4 cyclohexadiene. Ngayon, merong new convention on the writing of your uh, alkenes. So we have here, you start muna doon sa parent, so that's a cyclohexa. Then the 1 4 here, dito na natin ilalagay yung, so the numbers kung saan nakalocate, yung location, yung position ng double bond, ngayon ay nilalagay natin before the suffix in or die-in or try-in. So yung number, kasi ano, alam ko baka maging nakakalito kasi yon. So kaya yung convention ngayon is nilalagay na lang yung position, yung location ng double bonds doon sa gitna before the suffix in. So ito, pwede natin itong baguhin. So I'm saying na pwede natin baguhin ito. So ito will become 2-methyl hex 3 in. Ito naman will become hex 2 in. Here. So paano natin siya niniman? So you count the number of the carbons in the parent chain. So this one is 5 carbons. So naka-cyclic din siya. So that's why we will give a name cyclopentene. Then we start doon sa pag-number ng inyong substituents. So we have here 1, 2, 3, 4, 5. So at carbon position 1 and 5, meron kayong methyl. So dahil dalawa yung methyl, gagamitan natin siya ng prefix na di. So that's why this organic compound is named 1,5-dimethyl cyclopentene. So we have here some common names. So binibigyan din ng nire-recognize din yung common names ng some alkenes. Like for example, this one, this is ethene, but the common name is ethylene. So yung ethylene kasi yung ginagamit for ethylene is used for as a plant hormone. So it will induce ripening in fruit. So yun yung nagpapabilis ng pagpapahinog ng mga fruits natin. Then we have here propene. So the common name is propylene. So we have here 2-methylpropene. So you just count 1, 2, 3. So that's why it's a prop, met et prop. So propene. Then at carbon position number 2, we have a methyl group. So that's why this is 2-methylpropene. But the common name will be isobutylene. So you just count 1, 2, 3, 4. So meron kang 4 na carbon. So that's why it's a butylene. Then since ito ay naka-branch, it's an isobutylene. So this one naman is isoprene, the common name. So the systematic name or IUPAC name is 2-methyl-1,3-butadiene because it's 1, 2, 3, 4. So carbon positions 1 at between 1 and 2 and then 3 and 4 carbons meron kang double bond, so that's why it's a 1,3-butadiene. Then yung parent chain is 4 na carbons kaya siya butadiene. And then at carbon position number 2 you have a methyl group here, so that's why it's a 2-methyl-1,3-butadiene. So review lang nung naming ng alkenes using the IUPAC name. So to name an alkene, the parent name is that of the longest chain that contains the carbon double bond. So wag niyo kakalimutan 'yon. Dapat madadaanan yung double bonds. Then, you number the chain from the end that gives the lower numbers to the carbons of the double bond. So, mag-start ka kung saang end at dapat mabigyan natin ng mas mababang number yung double bonds. Then locate the carbon-carbon double bonds by the number of its first carbon. So for example, yung double bond is between 2 and 3. So ang gagamitin mo lang is yung number 2. So the information 2 is enough to to say na yung double bond is between 2 and 3. Then you use the ending "-in". So the suffix is "-in" to show the presence of a carbon-carbon double bonds. Then in the branch chain alkenes, so branch chain alkenes are named in a manner similar to the alkanes in which substituted groups are located and named. And yung isa pa dito is dapat mabigyan natin siya ng mas mababang number as per IUPAC rules. So another example lang, this one, ito is in uh, in accordance dun sa rule na sabi nga natin, dapat mag-start ka ng numbering kung saan mas malapit yung double bond. So, this is the end kung saan makikita yung mas malapit yung double bond. And interestingly, yung double bond is between 1 and 2. So, that's why it's a 1. And then you count the hydrocarbon chain. So, that's a 6 carbon chain long. So, that's why it's a hexene. So, the number is 1 hexene. Or using the new way of writing it, that's one hex. Hex 1 in. So 1 here means na the double bond is between 1 and 2. So ito naman ay iba mga examples. So nasabi ko na din ito, yung mga common names. And yung mga common names ay yun ay ina-accept din na name for those with low molecular weight. When say low molecular weight, ito yung meron lang 1, 2, this one is 3, this is 4. So 3, 2, 3, 4 carbons lang yung may common. Yung karamihan ng may common name is yung mababa lang yung mass. So for cycloalkanes naman, you number the carbon chain of the ring, double bond, 1 and 2. So yung double bond mo, it's either at carbon position 1 and 2. So automatic yon. So kasi ito ay ginagawa para mabigyan natin ng lower number yung double bonds at yung substituents din. Okay? So note that it is not necessary to explicitly number the position of the double bonds in cycloalkanes as in the linear alkenes. So hindi na nilalagay kung saan yung double bond. So it's automatic na understood na siya na when you have a cycloalkene, yung carbon position 1 and 2 sana ay nandoon yung inyong double bonds. Then number and list the substituents in alphabetical order. So I have here another example. So this one is yung double bond is between 1 and 2. So meron kayong direction na pwede kayong clockwise or counterclockwise. So if you use the counterclockwise direction, so you will encounter the substituent here. It's a methyl at carbon position number 3. Pero if you use the uh, uh, clockwise direction, so you'll start here at this is will become 1, this is 2, 3, 4, 5. So kapag clockwise direction, yung methyl group mo is at 5, carbon, fifth carbon. So di ba dapat nga mabigyan natin ng mas mababang number yung substituent. That's why the correct name is 3-methyl cyclopentene and not 5-methyl cyclopentene. So this is good for a monosubstituted uh, cycloalkene. When say monosubstituted, isa lang yung substituent dyan. Ito naman is disubstituted. So, meron kang dalawang substituents na makikita. Then, again, you start at carbon position 1 and 2 for the double bond. Then, you use trial and error kasi para malaman mo kung ano yung position ng inyong mga substituents. So, you have here a methyl group. This one is a methyl. And this one is met-et, so that's why this is an ethyl group. Ngayon, dapat mauna yung ethyl versus methyl as per alphabetization. So, yung ethyl natin. Ngayon, if we follow here, the direction is clockwise. So, may methyl group ka at 1. Then, at carbon position number 4, meron kang ethyl. But if you start here, kunwari lang, this is 1, 2. So, 2 methyl. Then, 3, 4, 5. So, it seems na yung inyong, uh, if you use the wrong direction, the ethyl group is at carbon position number 5. So, dapat, di ba sabi ko nga sa inyo, alphabetical sila. So, dapat mauna si ethyl and si methyl. Ethyl first, then methyl. Then, kung sino yung mas nauna na do sa kung sino yung mas nauna dun sa alphabetization, yung ethyl, dapat mabigyan natin siya ng mas mababang number. So, in this case, if you use the clockwise direction, you have 4 at carbon position, you have an ethyl, but if you use the wrong direction, the clockwise, you will end up at carbon position number 5. So, that's why 4 versus 5, you use the 4. So, that's why the correct name here is 4-ethyl, 1-methyl cyclohexene. So, alkenes that contain more than one double bond are named as alkadienes, alkatrienes, and so forth. So, those that contain several double bonds are referred to more generally as polyenes. So, you have a Greek uh, term here or Greek prefix, poly, it means many. So, na-discuss ko na naman din ito. So, these are just some of your dienes. And this one is a cyclodiene kasi meron kang cyclic ring. So for further information about how to name alkenes, you visit this link. So we'll now proceed with the physical properties. So in this slide, magkasama na yung alkenes and alkynes. So alkenes and alkynes are generally non-polar compounds. So paano natin nasabing non-polar compounds yan? Kasi, diba, remember, we are computing for the the electronegativity difference of your carbon and hydrogen bonds. So the carbon-hydrogen bonds are generally nonpolar. So yung buong structure natin na puro carbon and hydrogens will be nonpolar. Then, the only attractive forces between their molecules are London dispersion forces. So their physical properties are similar to those of alkanes with same carbon skeletons. Ang ibig sabihin lang nito is with same number of carbon chain, kung gaano kahaba yung carbon chain, nagkakaparehas yung physical properties ng alkenes at alkynes with the same number of carbons. So, alkenes and alkynes are insoluble in water. So, bakit siya naging soluble in water? And take note, it's only soluble in one another. So, if you mix two alkenes or alkynes together, they will be soluble in each other. But yung inyong alkanes and alkynes will be soluble only in non-polar organic liquids. So why is this the case? First, hindi siya soluble. Insoluble siya in water because you know that water is it's a polar compound. So if you mix alkenes and alkynes which are non-polar with a polar solvent like water, hindi sila magbi-mix because you know the rule, it's like dissolves like. So yun yung ating basis, like dissolves like. So in this second phrase here, soluble in one another because alkenes and two alkynes are mixed together, so they will be soluble in each other. And lastly here, it will only be soluble in nonpolar organic liquids. So when say nonpolar, yun nga, dahil meron tayong like dissolves like, if yung dinidissolve mo ay non-polar, dapat yung gamitin mong solvent should be also non-polar. Lastly, for the physical properties, yung alkenes and alkynes natin are liquid or solid at room temperatures. And ang kanilang density is less than 1 gram per ml. So bakit mahalaga tong value na 1 gram per ml? Because this is the density of water. Water. So if the density is less than 1, the tendency is it will float on water. But if you have a density greater than 1, then it will sink. So greater than 1 gram per ml, you will sink or the object will sink. But if you have less than 1 gram per ml, the substance will float. Okay. Now here we have calculating the degrees of unsaturations. So bakit mahalaga itong degrees of unsaturations? So if we start from the basic idea na alkenes have a fewer hydrogens than an alkane. Because as you can see here, diretso muna tayo do sa pictures, this one is two carbons. So parehas naman silang two carbons. But in the presence of a double bond, ilan na lang siya? Naging apat na lang yung inyong hydrogens. But in an alkane, like ethane, you have six hydrogens. So, kapag nagkaroon ka ng double bonds, ang difference sila is two hydrogens. So, para malaman nyo, yung formula for alkanes ay ginagamit natin is CnH2n plus 2. So, for alkenes naman, ang formula na gagamitin natin is CnH2n. So, bakit mahalaga yung pag-calculate ng degrees of unsaturation? Because this will relate the molecular formula to the possible structures. So, what do we mean by degrees of unsaturation? So, it is the number of possible multiple bonds. So, when you say multiple bonds, it could either be double or triple bonds or a presence of rings. And pwede ring combination. You have a ring structure na may double or triple bonds. So the formula for a saturated, a cyclic compound, when say saturated, lahat ng bonds ay single bonds. So when say single bonds, and then it's acyclic. So pag acyclic siya, it means hindi siya naka-ring structure. So itong sinasabi natin na saturated acyclic compounds, this only refers to alkanes. So yung alkanes, ang formula niya is CnH2n plus 2. So your alkanes has fewer hydrogens than an alkane with the same number of carbons like this one. Dalawang carbons pero nabawasan siya ng dalawa. So the formula for alkenes nga is CnH2n because of the double bond. So, sa pag-calculate ng degrees of unsaturation, you should take note o dapat tandaan nyo na kada dagdag sa bond from a single bond to double bond, dapat mag-alis ka or mag-remove ka ng dalawang hydrogens. So, if you start from like this one, ethane to ethylene na isang alkene, magbawas ka ng dalawang carbons to create that double bond. So, ito namang ethylene, if you want to make this an alkyne, mag-aalis ka pa rin ng dalawang hydrogens to create that triple bond. So, in the process, kapag gusto mong gumawa ng ring structure, inaalis mo din yung dalawang hydrogens. So, let's give an example. Like this one. This is C6H10. So, ang tanong natin is this saturated or unsaturated? Now, para malaman mo kung siya ay saturated or unsaturated, you first compute for the saturated formula, yung alkene. So, you have C6H2n. So, you multiply 2 times 6 plus 2. So, you have your 2 times 6, that's 12 plus 2, that's 14. So, the formula is C6H14. So, the saturated formula is C6H14. Take a look at the formula given. It's C6H10. So, ano ang nangyari? May apat na hydrogens na nawawala. And sabi ko nga sa inyo earlier na every two hydrogens, merong possible bond na na-form. So if you have four hydrogens that are not present, this only means na meron kang 2 degrees of unsaturation. So, ano yung mga possibilities ng 2 degrees of unsaturation? So you have two double bonds, o kaya naman yung lahat yung apat na hydrogens na yun ay inalis to make a triple bond, o kaya naman sabi ko nga sa inyo para every time na nag-aalis ka ng 2 hydrogen, makaka-create ka ng ring. So since apat na hydrogens yung nawala, possible na may 2 rings ka dito. O kaya naman it's a combination. So you have here a ring structure. So to create the ring, alis ka ng 2 hydrogens, and to create a double bond inside that ring, you need to remove also 2 hydrogens. In total, apat na hydrogens yung inalis mo. So, C6H10, what are the possible structural formulas here? We have here 4-methyl-1,3-pentadiene. So, it's a diene kasi meron kang dalawang double bonds here. It's a cyclohexene. So, 6 carbons kasi ito. So, hex, and then you have a ring structure. So, that's why you use the prefix cyclo, and then you end your compound with the suffix "ene." So, that's why it's a cyclohexene. Ito naman, it's bicyclohexane. So, kung mapapansin nyo dito, you have here 1, 2, 3, 4, 5. So, 5 here, and then ito, mukha siyang 3. Pero kasi, kung mapapansin nyo, dito sa side na to, actually, isa lang yung carbon. Kasi ito ay sinishare nila. So, that's why you have here a bicyclo. It's a bicyclo, 2 rings. But it's a hexane. Then, we have here a triple bond. So, the triple bond is used, and ito kasi ay pwede ding mailipat-lipat yan sa other positions. So, madaming possible structures ang ma-form mo using the given molecular formula of C6H10. So, paano natin, that's applicable only for hydrogens. Ngayon, 'di ba, meron tayong mga other elements na ginagamit like halogens. So we symbolize it as X. So we have halogens like F, Cl, Br, and I. That's why we will call this organic compounds as organohalogens. So a halogen will replace hydrogen here. So your halogen serves as a substituent. So yung halogens mo dito nagiging substituent siya. And every time na ginagamit mo siyang substituent sa isang organic compound, you replace your X. You replace H with a halogen or X. Here, so you start with a given molecular formula. So C4H6Br2, and then we have C4H8. Now, you start with this one, C4H8. Unahin yung gawin is to get the formula, to identify the formula for a 4 carbons na alkane. So we have here 4 times 2 times 2, so that's 10. So the saturated organic compound an alkane with 4 carbons will be C4H10. Now, dito sa ating formula, C4H8. So, it means meron kang dalawang nawawalang hydrogens. 2 hydrogens are removed. So, 2 hydrogens, that will be equivalent to 1 degree of unsaturation. So, dun sa ating magiging structural formula, may posibleng double bond. Now, dito sa formula na C4H6Br2, yung Br dito ay ginamit pamalit dun sa H. So dito sa example lang natin na structure dito, yung H dun sa magkabilang dulo, and may double bond between 1, 2, 3. So between 2 and 3. So there's a double bond between 2 and 3 carbons, and then yung H's dun sa magkabilang dulo, it is replaced by a bromine. Kaya yung ating formula dito, from 8 naging 6 hydrogens, and then yung meron kang dalawang Br sa magkabilang dulo. So if you add the numbers of the if you add you simply add the number of hydrogens and the halogen, you will end up with 8. So itong C4H6Br2 is just equivalent to C4H8. And since ang saturated formula is with 10 hydrogens, pero ito ay 8 lamang, so we have here 2 missing hydrogens and that will constitute 1 degree of one unsaturation, and that is a double bond present in your structure. So we have another type of compound, we called it an organoxygen. So that means it has carbon, hydrogen, and oxygen. And you know that oxygen forms two bonds. So kung may idodrawing lang ako dito, if your original bond is CC at gusto mo mag-insert dyan ng oxygen, this will become COC. So, hindi na bago. Nagdagdag ka lang ng oxygen pero hindi na bago yung orientation nila. Dun sa CH, pag CH naman, if you replace H with an oxygen, andun pa din yung H. So there is no change in the number of hydrogen atoms. Dito sa nauna kong dinawing kanina, so ito ay dalawang carbons, ito ay palibutan mo ng hydrogens. Kapag nag-insert ka ng oxygen dito, hindi mababago yung number of hydrogens. It's still 6. So, oxygen will not affect the formula of the equivalent hydrocarbons. So, in this case, pwede nating i-ignore. This may be ignored in calculating the degrees of unsaturation. So like for example, this one is C5H8. So the sa C5H8, ang ating fully saturated na compound will be 2 times 5 plus 2, so that's 10 plus 2, so 12. So you should have 12 hydrogens in an alkane. Pero dahil ang formula mo dito is C5H8, meron kang nawawalang 4 hydrogens. So, every pair of hydrogens na kulang ay equal sa 1 degree of unsaturation. So, dito, sa C5H8, meron kang dalawang unsaturation and that could be 2 double bonds. So, ito yung naging isang structure na na-drawing. So, meron kang double bond between 1 and 2. So, 1, 2, 1, 2, 3, 4, 5. So, between 1, 2, 1, 1 and 2, and then 3 and 4. Ngayon, yung H do sa dulo ng inyong hypothetical na drawing, ito ay pinalta ng O. So, nag-insert ka ng O dito, and since yung oxygen natin sa Lewis structure, di ba, ay dinodrawing natin siya na meron kang dalawang lone electrons. So, yung mga electrons ay yung for bonding. So, itong oxygen na to is nakabond kay carbon. Ito. So, ito ay kailangan mabond siya. So, yung inalis mo na hydrogen dito, doon pa rin siya. So, in this case, hindi naman nabago yung number ng hydrogens mo. So, that's why the formula with an oxygen C5H8 will become C5H8O. So, yung oxygen dito, you just ignore that. So, in determining the structure of your given molecular formula, hindi mo i-disregard mo yung oxygen. So yung process nga natin kanina, I started with determining the alkane formula ng C5. So that's C5H12. Then, since ito ay naging 8, kulang siya ng apat na hydrogens or may enlist ka apat na hydrogen. So that means meron kang 2 degrees of unsaturation and that could be a double bond, 2 double bonds. Okay? And then, nung nag-insert ako ng oxygen dito, hindi nabago yung number of hydrogens. Okay? So, ito naman ay medyo kakaiba kasi nitrogens. So, we have organo-nitrogen compounds. Unang ating dapat tandaan is nitrogen has 3 bonds. Bakit? Kasi if we go back to our Lewis structure, yung inyong Lewis structure ay meron kang N, then you have a an electron pair here, so hindi na sila makikipag-pair. And then we have 3 lone electrons. So itong 3 electrons dito yung makikipag-bonding. Kaya meron siyang 3 bonds. So, ano ang case naman sa organo-nitrogen compounds? Sa organo-nitrogen compounds daw, meron siyang nadadagdag na isang hydrogen sa isang related hydrocarbon. Like for this example, this one is again C5H8. Yung ating fully saturated kanina is C5H12. So dahil meron kang apat na nawalang hydrogens, so posibleng yung kaninang case na yon ay dalawang double bonds. So sa case naman dito sa drawing na to, meron ka ulit dalawang unsaturation at yun ay may isa kang ring structure and then may double bond doon sa loob ng ring structure mo. Okay, so ito yung na-drawing na structure natin. It's a ring. So, do sa process ng pagsara ng ring, kailangan mo mag-alis ng dalawang hydrogens. And then, to 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 create that double bond between any two carbons sa gitna nila, dapat mag-alis ka ulit ng dalawang hydrogens. So, in essence, apat na hydrogens yung naalis. So, ito lang yung hypothetical na drawing natin. So, madami pang posibleng drawings dyan. So, itong hydrogen dito ay inalis natin. Ngayon, that hydrogen will be ay malalagyan natin siya palitan natin siya ng nitrogen. So, itong nitrogen na to, since dapat tatlo yung bonds na naka-bond sa kanya, this nitrogen is already bonded to the carbon. So, that's 1 bond. Then, kailangan natin ng dalawa. So, originally, this is the hydrogen na inalis natin dito. So, ikabit natin siya doon sa nitrogen. Okay, so that's the second. Ngayon, kailangan natin ng 3 bonds. So, to create the 3 bonds ng nitrogen, magdadagdag ka ng isang hydrogen. So, every time we connect a nitrogen, so every time we connect a nitrogen, there is an additional hydrogen. So, paano natin gagawin ngayon yung inyong pag-calculate ng degrees of unsaturation. So you always subtract 1 hydrogen for equivalent degrees of unsaturation in an hydrocarbon. So ito yung may nitrogen. So yung nitrogen dito is equivalent to 1. So every nitrogen na nakalagay is nagdadagdag siya ng isang hydrogen. So in essence, itong formula na to is equivalent lang to C5H8. So your C5H9N is just equivalent to a formula with C5H8. So again, the process is to 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 get the fully saturated na compound na alkane, C5H12, may apat na nawawalang hydrogens, and that is used for possible 2 unsaturations. You have a ring and a double bond. In the earlier example, you have 2 double bonds in the structure. So in summary, so you always count the pairs of hydrogen below CnH2n plus 2. So this formula is for the alkane. Then you add number of halogens to the number of H. So, dito kasi, a halogen na naka-attach doon sa inyong structure is just equivalent to an H. Diba? Nasabi ko kanina na yung halogen, para maikabit mo siya doon sa carbon, mag-aalis ka muna ng isang hydrogen. So, in essence, the number of halogens will be equivalent to hydrogens. For oxygens naman, so you can, nakita natin kanina na kapag nagdagdag ka ng oxygen, I mean, kapag meron kang CH bond, at itong H na yan ay pinalitan mo ng O, naging O siya, so kailangan pa rin yan yung isang bond. So, yung inalis mo na H will be also bonded to oxygen. So, in essence, kahit magdagdag ka ng oxygen dito, hindi nababago yung number of hydrogen. So, you just ignore the oxygen because oxygen links to H. Then, for nitrogens naman, magsusubtract ka. Kasi nga, yung sa ating scenario nga kanina, if you have here a CC bond, itong CC bond na to ay maglalagay ka ng nitrogen dyan. Yan. So, ito ay 6 na hydrogens. Kung gusto mong maglagay dito ng nitrogen, so, may madadagdag na isang hydrogen dito. So, every time there is a nitrogen na nailagay, yung H dito, yan ay ibabawas natin dun sa formula. So, you subtract the extra H to arrive at the equivalent hydrocarbon formula. So, ito sa other case naman natin na CH, so kung itong CH na yan ay gagawin natin siyang, itong H to ay papalitan natin ng N, so, yung H na inalis mo, ay yun pa rin yung gagamitin mo, pero maglalagay ka pa rin ng panibagong H. So, dumadami. So, ang rule dito is you subtract every N that is equivalent to an additional hydrogen. So, you dapat bawasan mo siya dun sa formula. Okay? So, for more information about degrees of unsaturation, you visit this video. Our next topic is all about cis-trans isomerism. So before we start that topic, kailangan natin munang maglagay ng few background information. First, your CC bond, yung single carbon-carbon single bond, ito ay nakaka-rotate. But if you have a carbon-carbon double bond, this is not, it cannot freely rotate. So, every time you have an alkane, hindi nakaka-rotate yan. So, kung gusto mong ma-rotate itong portion na to, like this one, kung gusto mo itong CH3 ay nasa taas, kailangan mo munang, you need to break the bond first before it can rotate. So, meron tayong tinatawag na cis-trans isomerism. So, ito yung effect. Because of the restricted rotation, hindi nakaka-rotate yung carbon-carbon double bond. So, your alkane with two different groups on each carbon of the double bond shows cis-trans isomerism. So, in our case here, yung methyl groups natin can either be on the same side, or this one, opposite sides of the double bond. So, yung reference point natin, the double bond. So, saan makikita yung metal groups ay ito. Ito ay same side. So, same side, if this is the reference, yung double bond, CH3 mismo ay nasa same side. But ito naman, the reference here is the double bond, so opposite sila. So, we have here we denote yung organic compound na may found on the same sides as cis, And then yung opposite sides naman will be trans. So you take note, cis is for same side, and then trans for opposite side. So the cis-trans isomerism is applicable only to di-substituted. So when say di-substituted, mayroon kang dalawang substituents other than H. So as you can see here, meron kang H, pero meron kang dalawang substituents na bonded to the carbon-carbon double bonds. So nakikita nyo dito identical sila. So yung inyong yung inyong metal groups dito ay yun nga, it's either nasa same side sila nung double bond or magka-opposite sila. However, the cis-trans isomerism in alkanes, it requires that the end groups should differ in pairs. So cis-trans isomerism is applicable also to when both double bond carbons are attached to two different compounds. So ito, we have here two scenarios. So ang nakikita dito, meron kayong dalawang you have identical substituents D. So yung D na yan is found on uh, each side of the double bond. Ngayon, kung meron kang A and B, so yung position dito, the A here is sa top, and then dito ay nasa bottom siya. Itong dalawang compounds na to are just identical. Bakit? Kasi ito, class, pag itong compound na to ay rotate siya, you will arrive with the same structure here. So this one, the first scenario here, these are not cis-trans isomers. But on the other hand, itong letter B natin, you have here four different substituents A, B, D, E. A, B, D, E. Ngayon, these compounds are not identical now. Why? Because ito, if you rotate this compound, it will become B, C, A, double bond C, E, D. So, ni-rotate ko lang siya. So, ito is the same with this one. BA, yung D dito ay nasa taas, yung D ay nasa baba. So, if you rotate this one, this first compound here, it is not similar. Hindi sila identical. Therefore, this one is a cis-trans isomer. So, yung cis-trans isomer naming system na na-discuss natin will work only for a di-substituted alkenes. Ngayon, paano naman kung dun sa meron kang tri or tetra-substituted? When say tri, meron kang tatlo o meron kang tetra, 4 substituents in the double bond. And it will require a more general method in naming. So we will refer this method as the E-say system. So how is this E-say system applied? And how is it different? Is it may difference ba mamaya pag kinumpare natin siya with the cis-trans isomerism? So, Yung essay's stereochemical nomenclature will follow the priority rules of Kahn, Ingold, and Prelo. So in this process kasi, we compare where higher priority groups are with respect to the bond and designate as prefix. So we have here E, engkangen, it means opposite sides, and then say is susamin, it means together on the same side. So paano natin i-apply yung E-say nomenclature or E-say naming? So we will first compare yung mga meron tayong higher groups and lower groups. So higher rank groups here, as you can see, are on the opposite side. So if it's in the opposite side, so you use the E system, E designation. But if your higher rank groups, mamaya makikita nyo ano ba yung mga higher rank groups na pinagsasabi ko dito. The higher rank groups here are located on the same side of the double bond, so we will designate it as say. So may rules na sinusunod. First rule. The first rule says you must rank atoms that are connected at a comparison point. And then, ito yung mahalaga. Higher atomic number gets higher priority. So if you're familiar with the periodic table, the higher the atomic number, mas priority siya. So ito. So the prioritization, like for example, is BR. Siya yung highest, siya yung priority, and then lowest priority dito is yung H. Kasi yung H is the first element, and then the BR is the BR. Pang ilang element siya? 35. So we have here an example. As you can see here, we have a double bond. Yung inyong i-compare is H, CH3, Cl, and CH3. Ngayon, kailangan natin ng comparison point. So, to yung comparison point natin will be the double bonds. So, para magawa natin yung ranking, you consider the double bond carbon separately. So, this carbon is separate from this one muna. So, magka-separate muna. So, in this carbon, ang kailangan natin bigyan ng priority is hydrogen versus the CH3. Now, because yung C mo, may mas mataas siyang atomic number, so the CH3 here is the higher priority. Your H, because it's the first element, mas mababa yung atomic number niya, lower priority siya. Then here, in this part, you have Cl versus the CH3. Now, yung i-compare natin is Cl versus CH3. So, Cl is higher priority. Mas mataas yung atomic number niya than your C. So that's why the Cl here is a high priority and the CH3 is the lower priority. Now you compare the positions of your high ranking priority groups. So in this side, CH3 and Cl, ano yung positions nila? Is it on the opposite or the same side? So yung CH3 and the Cl, which are your high priority groups, are located on the opposite sides. That's why we will designate it as E. So E for opposite. Then, you proceed with the naming. So you always start naming the parent hydrocarbon chain na kasama yung double bond. So this is 1, 2, 3, 4. So met, et, prop, but. So but, may double bond, so butene. And then where is the double bond? It's 1, 2, between 2 and 3. So that's why it's 2 butene. Then you have a substituent na chlorine. And it is found where? So kung dito ka nag-start, this is 1, 2, 3. Pag dito ka naman nag-start, this is 1, 2, 3. So, yung chlorine natin dapat mabigyan natin ng lower number. So, that's why it's 2. So, the correct name for this one is E2-chloro-2-butene. Okay. So, that's for the first example. Ito naman. So, ganun ulit. Same scenario lang ito. So, kinumpare na yung H versus CH3. So, higher priority yung CH3. Then, CH3 versus the Cl. So, the higher priority will be the Cl. Now, since the Cl and the CH3 are on the same side, so we will designate it as say. So, say, then you just proceed with the naming as usual. So, this is say-2-chloro-2-butene. Now, there's rule number 2. So rule number 2 is if atomic numbers are the same, you compare at the next connection point at the same distance. Then, you compare until something has a higher atomic number, and then hindi magko-combine. You do not combine, but you always compare. So para maintindihan nyo yung rules na to, so let's say this is A, B, C. So we'll give some examples. So, yung scenario kasi dito is yung inyong substituents ay magkaparehas. Ito, may parehas kayong C. So, it means pantay yung inyong atomic numbers. So, sino yung magiging higher priority? Ngayon, you compare the next point of comparison. So, dito, yung carbon dito is bonded to a hydrogen. So, yung hydrogen yung i-consider natin. In this part, meron ka ulit carbon. So, ito yung i-consider natin. So, hydrogen versus carbon. So, mas mataas yung atomic number ng carbon. So, that's why this portion will be given the higher priority. O, ito naman. At the first comparison natin, may oxygen, parehas. Yung una mong ito, sa left side, may hydrogen na naka-attach kay oxygen. But in this on the right hand side nyo, yung oxygen is bonded to a carbon. So again, hydrogen versus carbon. So mas mataas yung atomic number ni carbon. So that's why this one will be given a higher priority. So ito naman. You have here same carbon. So may carbon ka ulit. Kasi nga, similar. C, CH3H. O, so ito. Parehas sila dito. Ngayon, dahil pare-pareha sila dyan, ang i-compare mo is yung mga iba pang substituents. So ito, this one is C versus H. Again, the rule is mas mataas yung carbon mataas yung atomic number ng carbon kaysa sa hydrogen. That's why this one will be given a higher priority. So ito naman. So in this case, meron kang carbon. So same. You have a hydrogen, so hindi mo mako-compare yan. Then we have here C and then N. So ngayon, paano natin bibigyan ng comparison? Sino yung i-compare natin dyan? Okay. Dahil chlorine yung isang atom mo dito at ito ay isang mataas ang atomic number nito, so automatically this one will be given a higher priority. So, yung may chlorine versus yung kahit N pa yan at carbon yan, since may chlorine ka dito, this will be given a higher priority. Next, rule number 3. So multiple bonded atoms are equivalent to the same number of single bonded atoms. Substituent is drawn with connections shown and no double or triple bonds. And then added atoms are valued with zero ligands themselves. So para mas maintindihan nyo, ito siya. So this one, meron kang carbon, double bond oxygen. So this carbon is bonded saan? Meron kang hydrogen at meron kang dalawang oxygen. So itong carbon double bond natin dito, tinitreat natin siya na dalawang oxygen yung naka-bond sa kanya. So ginagawa natin lahat sila na single bonded sila. Ano pa, dinedesignated natin sila na maging single bonds. Pero itong oxygen na to, ito naman, from the perspective ng oxygen, this oxygen is bonded to carbon-carbon. So, yung oxygen mo, oxygen mo, nakaband siya sa dalawang carbon. So, this one is equivalent to this one. Your carbon here is bonded to an H, an O, and an O. This one, yung oxygen sa original natin, is bonded to, kasi di ba may double bond, carbon, carbon. Okay? So, ito yung video for the naming of the ESAY naming scheme. So, let me give an example pala muna before we proceed. So, we have here, I will draw it. So, yan. So, we will assign the ESAY configuration to the compound. So, anong strategy natin dito? Is first, yung ating ititreat natin siya as separate. This carbon is separate from this carbon. So, the left-hand carbon, meron siyang hydrogen and CH3 substituent. So, yung comparing it, yung inyong carbon will have a higher atomic number. So, this one will be given a higher priority. So, this one is lower. So, on the other hand naman, yung right-hand carbon mo, meron ka itong CH3, 2, and then CH2OH. So, ito, by rule number 1, meron silang, so i-drawing natin, C, H, CH3, CH3. So, ito, dinowing ko lang siya ganun. Tapos, ito naman ay C, H, H, O, H. O, yan. Ngayon, by rule number 1, as we compare it, I use another color, yung carbon mo, same. Okay? So, equivalent sila. By rule number 2, dahil may oxygen dito, kahit may carbon ka pa dyan, may mga carbons ka dyan, so yung oxygen dito, the presence of the oxygen will make it a higher priority. Okay? So, higher priority ito. Ngayon, we compare the position of your high and low, yung priority, yung high priority groups mo. So, your priority group in this part is CH3, and then in this part is CH2OH. Now, determine the location. Is it on the same side or the opposite side? Since they are on the same side, so this one is a say configuration. Okay? So the two higher rank groups are on the same side of the double bond. So we assign the say configuration. So for more info, you visit this link, which is also included in the module. So you click this and then you watch the video. Now we go to the discussion on the stability of alkanes. The basic question here is, alin ang mas stable? Is yung cis alkenes ba o yung trans alkenes? So the answer here is the cis alkanes are less stable than trans alkanes. Again, nasan ba ang mga trans alkanes natin? When say trans alkanes, they are on opposite side. But you have the cis, same side. So bakit nagiging less stable daw yung mga cis alkenes? For example, this one. We have here your CH3s are on the same side. So yung CH3s and yung CH3s mo kasi ay nagkakaroon sila ng steric interaction. So may kasi dahil ito ay parehas na malaking portion ng inyong molecule, ayaw nila ng gusto nilang magkalayo sila. So kaya dapat mas favored yung on the opposite sides yung inyong mga bulky groups like CH3. Okay? So paano ba and I forgot to mention kanina na because of the restriction do sa rotation sa double bond, there's a way to convert your trans to cis. So that involves the use of acid catalyst. So we will convert here we will convert the cis with the trans. So gagamit tayo dito ng acid catalyst. And then it was found out na mas madami yung amount na na-produce ng trans na compound kaysa do sa cis. Kasi class, yun nga, hindi favored yung mga yung mga bulky groups mo na yung mga bulky groups mo dito ay magkaharap sila o magkatabi sila. So mas stable sila kapag magkahiwalay sila or they are apart from each other. So that's why if you use the acid catalyst to interconvert your trans to cis isomers, mas favored pa rin yung formation ng inyong trans compound. Okay? And in terms dun sa number ng substituents, this part, the more substituents present in your compound, it is more stable. So the trend here is tetra, so 4 substituents is more stable than the tri, than the di-sub, and the mono substituted alkenes natin. So you just take note of this one. So again, cis alkenes are less stable because of the steric hindrance. Yung steric hindrance will be, it means na dapat yung inyong mga substituent, larger substituents ay dapat hindi sila dapat magkatabi. So dapat sila ay mas maganda na apart sila from each other. Okay? So that is for the stability of your alkenes. So for more information, you visit this video on the stability of alkenes. Okay, so this will be the last part on the discussion of alkenes. So we have here the reactions of alkenes. So the most characteristic reaction is the addition to the carbon-carbon double bonds. So in this process, the double bond is broken. So we have here, the double bond here is broken and single bonds will be formed. Generally, itong double bond C ay very reactive. So that's why meron tayong meron tayong mga reactions in which your alkene will react with HCl, with your halogens, with water, and even H2 or hydrogen gas. Ang gusto ko lang i-point out dito, class, is yung
Dahil nga ang reactive dito is yung ating carbon-carbon double bonds. Itong mga single bonds natin, carbon-carbon single bonds, are generally unreactive. So, kung mapapansin nyo dito, we have here a double bond. One double bond. And here, between H2, Br2, yung between water, kasi di ba water is, yung drawing niya ay ganyan. So, may mga single bonds, HCl, ganun din. So, meron dito mga one single bond. So, if we react one double bond and one single bonds, after the reaction, there will be three. So, we have one, two, three. So, three single bonds will be formed. So, just to give an overview, so your alkanes will react with water, so that's called a hydration reaction. So, it will react with H2, so that's hydrogenation, also called reduction reaction. We have here Br2, it can be Cl2, I2, and F2. So in general, we call them halogenation. But if you want to be specific, kapag Br2 yung gamit mo, that's bromination. Pag F2, fluoridation. Pag chlorine, chlorination. And iodation. Then we have here HCl. So that's hydrohalogenation. So yung term is when you react with you react your alkene with HX. You just give it a general formula HX. The reaction is called hydrohalogenation. So, most alkene addition reactions are exothermic. So, the products are more stable and in lower energy than the reactants. So, kasi ka dito, yan, one double bond and one single bonds are replaced by three single bonds. And generally, the three single bonds here are stable. Mas bababa yung energy nila. So, the lower the energy, it's more stable. And in the process, it releases heat. So when we say exothermic means you release heat. So just because they are exothermic doesn't mean that alkene addition occurs rapidly. Hindi. So medyo may kabagalan pa rin yung mga reactions. So the reaction rate depends on the activation energy. When say activation energy, you must supply enough energy doon sa reaction for it to proceed. And in the process, para mas mapabilis o para mas mapabilis yung reaction, we always use a catalyst. So when say catalysts are they join the reaction pero hindi sila nako-consume sa reaction pero napapabilis nila yung reactions. So we have here addition of HX. So your HX, this is first reaction natin. This is called hydrohalogenation. So addition of HX it could be HCl, HBr, or HI. So addition of HX to an alkene gives a halo alkane, or in other terms, this is alkyl halide. So the hydrogen adds to one carbon at the carbon double bond, and yung halogen will bond to the other carbon. So we have here ethylene reacts with HCl. So the product is called chloroethane. So you have here a chloride. So yung chloride dito, papalitan mo siya ng term na chloro. And since this is 1, 2, met, et, so this is ethane. So this is chloroethane. So yung sinasabi ko kanina na yung H nyo will bond to the one carbon and the halogen will bond to the will be added will be attached to the other carbon. This reaction is regioselective. When you say regioselective, merong direction. So when you say regioselective, a reaction in which one direction of the bond forming or breaking occurs in preference to all other directions. So when in short lang, in regioselective reactions, may mas preferred na direction yung pag-attach ng inyong hydrogen and your halogen. So one direction of bond forming or bond breaking occurs in preference to all other directions. And this is called Markovnikov rule. So your H, your hydrogen, adds to the less substituted carbon and the X or the halogen is attached to the more substituted carbon. So like for example, this one is propene. It will react with HCl. Yung HCl mo kasi class will, di ba HCl yan? Pag hihiwala yan, it will become H and then Cl. So your H now will be added to the less substituted carbon. So in other words dito, when you say less substituted carbon, mas madami yung H niya. At yung more substituted carbon is lesser yung H. So, more yung portion ng compound with the higher number of H, doon ilalagay yung inyong H from the HCl. So, H adds to the carbon of the double bond with greater number of hydrogen. So, for example, this one, itong portion na to, itong carbon 1 is attached to 2 hydrogens. Itong carbon na to, si carbon number 2 ay attached lang sa isa. So, in Markovnikov rule, yung H dun sa naghiwala na HCl, yung H will be bonded to this portion. So, dito maa-attach yung H, and then yung Cl will be attached to the carbon number 2. That's why the compound na mapoproduce mo dito is chlorine attaches to the second carbon. And the name is 2-chloropropane. This one is not formed because of this rule. So, ito si Markovnikov, isa siyang scientist na experimentally ay na-determine niya na yung inyong H ay mas nag-attach dun sa carbon na mas madami yung hydrogens originally, and then yung halogen ay mag-attach dun sa mas kakaunti yung hydrogens na naka-attach dun sa carbon na iyon. So, this reaction is your hydrohalogenation reaction. Now, we will proceed now to this one. This is called addition of H2O or water. So this is called hydration reaction. So hydration is acid catalyzed. So it means meron kang participation ng acid. And most commonly used is H2SO4 or sulfuric acid. So hydration also follows Markovnikov rule. So the adds or attaches to the less substituted carbon, and the OH adds to the more substituted carbon. In other words, yung H, ma-attach siya dun sa carbon na mas madami yung hydrogens, and then yung OH will be attached dun sa carbon kung saan mas kaunti yung hydrogens. So let's give an example here. So we have here ethylene. So ethylene and then water. So yung water pala dito, 'di ba? HOH 'yan. So your water will split into H and then OH. OH plus. OH minus and H plus. So yung H plus will be attached to one position on carbon and yung OH will be attached to another carbon. So ito, since uh, kasi ito ay same number of hydrogens, so pwede namang mag-attach yung inyong hydrogens dito. So we'll attach the hydrogen here and then the OH will be attached here. So, in essence, mawawala yung mabe-break yung double bond natin, it will become a single bond, and the H will attach to the carbon here, and then the OH will attach to the carbon here. So that's why your ethylene will become now ethanol. So dito mas ma-appreciate nyo yung sinasabi natin sa Markovnikov rule. So you have here propene. So this is 1 and 2 carbon. First carbon, second carbon. So your hydrogen is sabi is mag-a-attach siya doon sa mas madaming hydrogen doon sa carb ulit. Si yung H from the water mag-a-attach siya doon sa carbon kung saan mas madami yung hydrogens. Eh nasaan ba yung mas madami yung hydrogens? So carbon 1 ba or carbon number 2? So ang answer natin is yung carbon number 1 ay may dalawang hydrogen. So in this part, dito mag-a-attach yung hydrogen. And then at carbon position number 2, dito mag-a-attach yung OH. That's why your CH2 here will become this one, CH2 and then H. So in essence, ito ay CH3. And then itong CH na to, dito ma-attach yung OH. So you have here propene with hydration reaction catalyzed by your sulfuric acid, it will become 2-propanol. So, ba't siya naging propanol? 1, 2, 3. So, met et prop. So, prop, dahil siya ay may OH, that's all. So, propanol. Ngayon, nasaan yung OH? It's in the carbon position number 2. So, that's why it's 2-propanol. This one. This is 2-methyl-propene. So, bakit siya naging 2-methyl-propene? So, 1, 2, 3, met et prop. So, propene. Prop, met et prop. And then, mayroon kang double bond. So, propene. Then, where is the double bond? So, sabi nga natin, you start the numbering from the side or the end na mas malapit yung double bond. So, we have here 1 and then 2. So, the double bond is between 2 and 1 carbon. And then, yung methyl group is naka-attach dun sa carbon position number 2. So, that's why the name is 2-methyl-propene. Then, we have here addition of water. So, hydration reaction ulit with the sulfuric acid. So, that's why your hydrogen will attach here again. Dun sa carbon na kung saan mas madami yung hydrogen. So, hydrogen will attach here and then the OH will attach in this position sa second carbon. That's why in your product, so H attached here in the first carbon, so CH3 na iyan, and then yung OH will be attached to the second position. So that's why ito yung magiging structure niya. Okay? So the name is 1, 2, 3. So met et prop. So propanol dahil may OH. Where is the OH? At carbon position number 2. And then you have another substituent which is methyl. So where is the methyl? It's in the second carbon position. So that's why the naming is 2-methyl-2-propanol. So in hydration reaction, yung water mo, the H2O will split into H and then OH. The H will be attached dun sa carbon kung saan mas madami yung hydrogen At yung OH naman is mag-a-attach siya doon sa carbon kung saan mas kakaunti yung hydrogen. And this is again following the Markovnikov rule. So that's it. That's your hydration reaction. Ngayon, paano naman yung inyong addition of chlorine gas and Br2? So this one is halogenation. So if this is Cl2, that's chlorination, and then Br2, it's bromination. Ngayon, addition takes place readily at room temperature. And paano ba ginagawa yung reaction? So the reaction is generally carried out using pure reagents or just mixing them in a non-reactive organic solvent like uh, this one. This is your non-reactive solvent CH2Cl2, that's dichloromethane. So we also call this as DCM. Okay. Now, dahil ito ay same naman, Cl and Cl, so your Cl, di ba, that's Cl2. So your Cl gas will break into two Cls. Okay, Cl minuses. So magiging ano siya, Cl minus. So yun ay mag-a-attach doon sa carbon. So ito, kung bromine yan, so magse-separate yan into 2Br minus, tapos so mag-split yung Br2 mo into Br, and then it will attach doon sa carbon nyo na involved dun sa double bond. So in this reaction, 2-butene reacts with Br2, it's DCM, so your bromine will be attached doon sa carbon. Okay? So yung cyclohexene mo naman is mag-a-attach siya dito. So that's why at the end of the reaction, it will become 1,2-dibromocyclohexane. So para saan ba tong halogenation reaction na ito? So in halogenation reaction, it can be used as a qualitative test. So how? Yung Br2 kasi, Br2 is deep red in color. So if for example, your Br2 here is red in color, if your Br2 reacts with an alkane, at the end of the reaction, mawawala yung red coloration. So, kapag yung Br2 mo ay dinagdag mo sa isang compound na paghihinalaan mo na alkane, pag nawala yung red coloration, that means the sample na kung saan nag-react yung Br2, that is an alkene. Okay? So, addition of Br2 is a useful qualitative test for the presence of carbon-carbon double bond since Br2 has a deep red color and yung dibromoalkanes mo are colorless. So, I will be giving you a video in a separate instruction, an example of this bromination reaction. Bromination reaction, reacting with an alkene. So it can be used for a qualitative test. Okay. So this will be the last one. So addition of H2. So H2 is hydrogen. So we can call this reaction as hydrogenation, or it can also be a reduction reaction. So it is also called catalytic hydrogenation. So isulat ko, catalytic hydrogenation or catalytic reduction. So bakit siya catalytic? May term na catalytic hydrogenation and reduction kasi in the process of this reaction, you use catalyst. Okay, so virtually all alkenes will add H2 in the presence of a transition metal catalyst, commonly palladium, platinum, or nickel. So paano ba ginagawa ito? So your catalyst should be finely powdered solid. So pinupulbos nila yan, then it will be dissolved. I-dissolve yan in ethanol. So this one is ethanol. Then you add the solid catalyst. Ulit pala. In the process ng catalytic hydrogenation, gumagamit tayo ng finely powdered solid. Yun ay i-dissolve in ethanol. So yan na nga, na-dissolve na yung, inad na yung catalyst. And then, i-expose mo yung inyong alkene with hydrogen gas. At ito ay mataas ang pressure. So, pressurized to. So, ganun yung process ng catalytic hydrogenation. So, let's give an example here. So, you have here trans-2-butene and cis-2-butene. O, anong difference nila? Yung positioning ng CH3s, yung mga bulky groups mo ay opposite for the trans. And then, you have the CH3s here at the same side of the double bond. So, that's why it's a cis. Ngayon, you just add your hydrogen gas. So in the presence of palladium, so that's the catalyst, so that is at room temperature, so 25 degrees Celsius at 3 atm. So itong 3 atm na yan is a measure of pressure. So mataas yung pressure niyan. Okay? So maalin man dyan yung trans-2-butene and cis-2-butene with the presence of your hydrogen and the palladium as the catalyst and pressurize yan, yung inyong pressurize yung inyong hydrogen gas, it will end up producing your butane. So, paano ang nangyari in the process? So, dahil naman ang H2 gas is H8, so mag-split yan. So, yung H na yan will attack kahit alin dyan. Di ba? Parehas lang naman. So, they will attack this carbon and in essence, itong double bond will be broken. That's why you will have here ito. So, pag ito, i-dignowing natin siya, CH3. Oops, teka. Parang di ko madawing ng ayos. So, ito ay become CH3. Naka-attach siya sa dalawang H. So, ito ay magiging CH2 na yan. And then, C. Meron ulit dalawang H. And then, this one is CH3. So, ano napansin nyo? Naging alkane na siya. So, from your alkene, naging alkane. So, in the process of catalytic hydrogenation or catalytic reduction, your alkenes will become fully saturated. So, that will become an alkane. So, let's give an example here. This is cyclohexene. So, its ring structure, 6 na carbons. Meron kayong double bond somewhere in between 2 carbons. So, that's why it's cyclohexene. You add hydrogen gas in the presence of your catalyst and then pressurize yung inyong hydrogen gas. So, what will happen? So, mag-a-attach yung hydrogens dyan. Diba? So, in the end, mawawala yung double bond. And ito, diba, sabi ko kasi inyo, in, in interpreting your line angle formula, so bawat kanto ay may carbon at meron niyang naka-attach na dalawang hydrogens. So what happened? Your cyclohexene after hydrogenation reaction will become your cyclohexane. So ito lang yung process. So yung metal surface, this is your alkene. So yan yung alkene mo. Ito mga yan, yung mga bilog na yan, that's your H. So what will happen is this carbon, this is carbon, it will react with this one. So, yan. Kaya naging ito, naging CH3 siya. Ito ay originally CH2. Then, the other carbon will also react with this H. Yan. So, what will happen? It will become CH3. So, yung inyong CH2 kanina na alkene, it now will become an alkane using the process. So this is the addition of hydrogen to an alkene remove involving a transition metal catalyst. Okay? So that ends our lecture discussion on alkenes. Thank you and have a good day.